Welcome everyone to week number 2 in Science 200. I'm so glad that you're still with us here and that you've completed some of your assignments, hopefully all of them so far, but we'll talk about that. And one thing before I move off this slide, any photographs that you see in my presentations are mine. This is a picture of a lighthouse when we were going out on one of our whale watching trips, me and my sister, in 2019. I thought it was just a beautiful, beautiful lighthouse. All right, so last week, we always do a little review of what you did before and then head into what you're doing this week. So last week you learned about the natural sciences, so astronomy, geology, environmental science, chemistry, physics, biology, what they are. What are those sciences and what is involved with each one? And you sort of picked in your discussion board post the science that interested you the most. A whole lot of you said astronomy, which I was surprised about. But anyway, it's an awesome science. Of course, I'm a biologist, so I love biology, but I also love environmental science because environmental science is really tied to a lot of the different natural sciences, including biology. So you learned about the sciences, and then you learned about how science works. Science does not work the way that you learned it in the 7th grade in a biology class, right? Form a hypothesis, design an experiment, do the experiment, get your results, come to a conclusion. Okay, science is way more complicated than that when you actually do science. There's a lot of repetition. For example, in your experimentation, you don't do it once. You don't do your experiment twice. You don't do your experiment 3 times. You do it over and over and over and over and over and over and over again until you make sure that the results that you get every single time form some type of idea, give you some type of result. If you keep getting different results every time, you have to start over. That is not going to work out for you. You can't do that. Something is wrong with your experiment, something is wrong with your thinking, something is going on with the phenomenon that you're trying to test. So you have to work that out. And so the most important part about science is that you publish your work. Once you have it all finished, you publish in a peer-reviewed journal so every other scientist on the planet can read your work and critique it. Take a look at it, see if it makes sense. See if that scientist in that discipline agrees with what you've done. Do they see any mistakes in your work? And that's very important. So you have to have that peer review. And then what does that lead to? You take a lot of ideas in science and you see if you can make sense of something that happens in the world. And that's what science is all about. We're trying to make sense and explain things that are happening in the world. If enough evidence comes about and you look at it and you say, well, that's not exactly the way we were thinking about this topic, you have to change your thinking, and that's the importance of revision. You have to take the information that you're given and see if it fits with what you already know, and if it does not, then you have to change your thinking. That is terribly important. Do we see much of that in the world today? No, we do not. I mean, people are so rigid in their beliefs and their ideas that they don't change their ideas and their thinking if new information comes along. I mean, if you need an example of that, just think about COVID. So anyway, that's the importance of revision in science. You also chose your topic that you will continue with through this whole term. And a lot of you chose electric cars, which I was also surprised at. My nephew has a Tesla, so I know a little bit about electric cars, even if I am a biologist. Some of you chose genetic engineering. Then we had some independent projects that came up, permafrost and that sort of thing, and all of those were good. So I can't wait to see what you do with your topics, and that continues this week. Okay, so this week, what is going on? You're going to go through Chapter 2 and answer all the questions about Chapter 2. Chapter 2 is all about cholera. Cholera is a disease caused by bacteria passed along through water normally. And the big controversy back then in the 1800s in London was that diseases were passed basically through the air, through unhealthy vapors. And that's called miasma, those unhealthy vapors. And so that was the public health thinking during that time, that all diseases were transmitted that way. Of course, we know now that there are lots of different ways that diseases are transmitted, including through food and water and mosquitoes and, oh my goodness, aerosol droplets, all sorts of ways. Cholera is transferred or passed from one person to another, usually by contaminated water. And so the city of London back in the 1800s was not very sanitary. People went to the bathroom in their homes. Some of that waste went into cesspools. Some of it went on the ground. Yeah, there was a lot of issues with sanitation back then, and they tried to fix that. They also had public wells, and some of that wastewater ended up in some of those public drinking water supplies. So you're going to learn about that in Chapter 2. Cholera produces a disease called rice water stool. You know what stool is. And it looks like rice water because so much fluid is coming out of your body through the infection by these bacteria that you become dehydrated and can die within a day, really, because your body just releases all the water from it. And of course, you can't survive that. Not a lot of the time. You have to figure out a way to rehydrate if at all possible. And this was just a very devastating disease back in those times. And it still is if you come across it. Sometimes you'll see this pop up in places like Haiti after a hurricane has gone through, something like that, where people don't have exactly the best sanitation and they're drinking contaminated water and that sort of thing. So it still pops up sometimes. So you're going to learn about the importance of clean water. Like I said, miasma, which is these unhealthy vapors, which there are diseases that are passed through the air. So don't negate that. But all diseases are not passed that way. You learn the importance of public health and public health laws, and boy, have we experienced some of that with COVID also. And you're going to learn about how science works and how it changes our thinking. You're going to learn about studies that John Snow did back in the 1800s and how he mapped out the cases of cholera and showed that miasma could not possibly explain what was going on, and in fact, it looked like contaminated water sources were what was the transmission mode back then. So you're going to take a look at Chapter 2 and answer all those questions. I do have to say I've been through it all, and I do have to say that a scientist did not write this work because there are a lot of pages and a lot of story. If I had been writing this, it might have been 3 pages long because I'm very succinct. But somebody in literature, like my friend who was an English major, has a PhD in English literature, she could have written this because it is very full of verbiage, shall we say. So anyway, but it's a good read. So read through that to understand how science works. And then you're going to work a little bit more on your topic. So you're going to make sure that you have outlined and discussed your issue. What exactly is your issue? I mean, electric cars, boom, is not an issue. All right, so you're going to discuss that and also the significance of this issue. So if you're talking about permafrost, who the heck cares if ice melts? Okay, big deal. What's the significance? If you chose something like coral bleaching, okay, so the coral reefs are dying, big deal. Why is that important? Why is that important to me sitting here in my chair right now? So you see, you have to find the significance of a topic in order for somebody to want to listen to what you're saying about the topic. Because if it doesn't affect me in some way or the grand scheme of things, I'm probably not going to listen. So you've got to figure out the significance of your particular topic. All right, and usually I like to give you a tip of the week to help you with your studies. And so after being through that chapter after going through that chapter two, I would suggest that you break up your assignments into manageable pieces. And so go through it, do a little something every day, or if you're at work and you have a chance to take a break and you can read through one section of chapter 2 and answer a couple of questions, go for it. Break up your assignments into manageable pieces. Do not wait until Saturday night. I know that's hard to do, but don't wait until Saturday night or Sunday night, really, before you turn in your assignments, because you'll get behind if you do that, and you'll be rushing to get it all finished. So please do break up your assignments into manageable pieces and get it done little by little by little. And that way, you'll be fresh every time you start a new little section. Okay? If you have any problems, if you have any questions, I am available to you. m.sigmon@snhu.edu. Please let me know. Please just email me. I'm always checking my email messages. So I'll email you back as soon as I possibly can. And with that being said, I hope that you have a wonderful day. This is the 4th of July today, so I hope you have a wonderful day celebrating Independence Day, and I hope you have a wonderful week.